All right, so let's check out this guy right here. So we're going to be solving this absolute value equation, but this has one little trick here. All right, so we've learned that if you have an absolute value in the form of ax plus k equals b, then you would do ax plus k equals negative b, and you would do ax plus k equals b. All right, so we know that this is how you create both of your equations. Now check this out. Notice that the way that this format is written in. If you look at the left side of our equation, notice that the the absolute value is isolated, meaning that we don't have a coefficient right here, and maybe like I'll just call this d, and neither do we have something added or subtracted right here. All right, so that is an indication that if there is something that's multiplied, if it has some kind of coefficient, or if if it has some kind of sum or difference, then we need to first get rid of those things, move it to the right side, and then we can go ahead and proceed on. So look at what we have right here. Notice that on the left-hand side, the absolute value on the left side is not by itself. And so since it's not by itself, we need to get it by itself. So we need to get rid of this plus 1. So we're just going to use our properties of equality. So we're going to subtract 1 on both sides. And we have the absolute value of x plus 4 equals 1. So now it's in this form here where we have the isolated absolute value. So now we can go ahead and write our two equations. X plus 4 equals 1 and x plus 4 equals negative 1. And both of these are solved quickly. So one answer is negative 3 and the other answer is negative 5. All right, and we just need to solve here. We're not graphing, so negative 3 and negative 5. And once again, you can always check your answer by plugging in these little guys back into here, and you better get 2 for both of them so you know that your answers are correct.